Okay, so in this chapter, we'll introduce energy security. We'll talk about definitions of energy security and the main concerns and indicators of it. To start with, how we can, when we say energy security, we can think about several factors, not only one. So first, from a scientific point of view, we can define the energy security as following. We know that energy can be neither produced nor consumed, and this is why we can talk about conservation of energy. While the quality of energy is always declining, and energy security is a matter of understanding thermodynamics and physics of energy. So, from thermodynamic courses, if you remember, you always have conservation of energy. You cannot create energy. Okay, but we know that if you remember from thermodynamic courses, we have entropy production. So the quality of energy can change. Okay. Now, concerning the economic view, energy security can be considered as a matter of analyzing transactions between buyers and sellers and minimizing the external costs of these transactions. So, whenever we want to have, if you want a security on the economical level, we try to reduce fluctuations in cost. We try to minimize additional cost related to energy. If we want to consider the social welfare view, we can consider energy services as a social necessity, and people have a fundamental right to energy for different applications as heating, cooling, lighting, cooking, transportation, etc. And the central value in this case will be equity. So we need to provide energy in equal way to people. And energy security is distributing energy services to all social classes without having differences between them. Now, on the ecological point of view, we can consider that energy security is a matter of recognizing that energy resources are finite and interdependent, and that present use will lead to a risk for the planet and future generations. So we should pay attention always to have like sustainability. We should pay attention to conserve resources for future generation. From this point, we can talk about energy security on the sustainable level and ecological level. Now, also, we can look at the political view. Whenever we talk about energy security, we can define it in political view as a key component of national security, and correct policies becomes a matter of maintaining economic vitality and military strength. So we should always have regulations that can ensure a security of the nation, and this can help us into having energy security. So as we can see, we can understand energy security in different ways. And in general, we try to look at these different ways of defining energy security, not from one side, but we'll try to to take into consideration all different sides of energy security. So how can we reconcile these views? One way is that the energy security should include the interconnected dimensions of availability, affordability, efficiency, and stewardship. So we don't look just at one side. We try to consider to compromise between all of these. So we should check always whenever we talk about energy security, we should tackle different criteria, not just one. In order to verify that it's available, affordable, efficient, we are using it efficiently, etc. And for example, when we talk about availability, okay, then we can tackle the independence and diversification of energy. So we have it from several sources. A good way of ensuring the availability criteria is not to rely just, if you want, on one resource. We should have several resources, because in this way we can be secure. And let's say if one resource is not available anymore, we can go to the other. And for example, you know that if we take into example the recent war that took place between Russia and Ukraine, you can see that because we had a lot of use of fuel, let's say, from one of these two countries, this made like a big problem when we have this political conflict. And that's why it's good to have several resources let's say for fuels, we don't rely just on one country. We should buy fuel from several countries. In this way, we can be secure if one of the countries has problem or cannot export anymore, etc. In addition, concerning affordability, when we talk about affordability, then we can tackle equity. So, and here we consider providing energy services that are affordable for consumers and minimizing price volatility. So whenever you give it in a if you want in a good way, you give it to all people, then you will reduce and you will minimize price volatility, because you don't have parts that will have it and other parts that doesn't. Whenever you have you don't give it in a if you want in an equal way, then parts who have a lot of excess will can control more the price, and this will lead to fluctuations in prices. On the other side also, we can talk, of course, whenever we talk about security, it's good to tackle energy efficiency, because larger is the efficiency, larger is the production of energy. So then we can tackle the innovation and education point of view. Okay, so we can work on research and technological development in order to improve the performance of energy equipment. And of course, also we should try to alter the consumer attitude. So we should always provide education, how to conserve energy, how to increase the energy efficiency use. We tackled this at the beginning of the course, and you have a lot of strategies, and sometimes we cannot just rely on consumer attitudes, but we can introduce some technological developments like sensors that can control the use of energy, and when we don't need it, the sensors will allow us to save energy. Now, concerning the stewardship, then we can talk about social and environmental sustainability, so we can protect the natural environment, communities, and future generations. So if you want, then we talk about, to facilitate, if you want, the different aspects, we talk sometimes about the 4 A's for energy security, which are the availability, the accessibility, the affordability, and the acceptability. And we link each of these, okay, two main elements, which are, for example, the availability will be related to geological existence, the accessibility to geopolitical elements, the affordability to economical elements, and the acceptability to social and environmental elements. And we have just discussed all of these aspects. So this is a way to tackle energy security in 4 dimensions. Now, we can also categorize, if you want, energy security in other form that is also similar to this one. We can say that we can identify the following main element for energy security definition. First, the first and most dominant element will be the availability of energy to an economy. This entails an element of absolute availability or physical existence. So, you know, for example, if we take, let's say, fuel as an example, okay, you have in some countries, you have a lot of resources, you have high availability. And this is why these countries, let's say, on the political level, will be able to control the market of fuel, for example. So the availability is a very important aspect, because it gives you a power, and it gives power to the country to be able to ensure the energy existence and to, if you want, use these resources. Another factor is accessibility, which is due to the largest spatial discrepancy between consumption and production of resources. And sometimes even you have, let's say, you have resources, but you are not able to access them. Okay, so this will be related to geopolitical implications. Like, if you want, we can take the example of Russian gas and Europe. In addition, we have the element of cost that in most interpretation is used a lot in interpretation of energy security, because you know that we need to come up with regulations to control the variation in the cost. Sometimes we can have a lot of fluctuation in the market. So on the international level, we should have some regulations that can help us into avoiding high volatility in cost, and avoid that we have like aggregation of resources into one region, and we should try to avoid, if you want, that we should have regulations to force this country to export to other parts, and not just be the only one to control this resource. Plus, we have some definitions also will include, as we discussed, the sustainability factor, because the sustainability factor is very important on the ecological level, since we don't only need to preserve, if you want, the rights of current generation, but also we should look at a future generation. We should try to ensure energy security for a future generation. For example, here we can see the coverage of each energy security team and energy security definitions by time period has changed. And this is why, if you want, like we talked before about the weights, you know that in each cases, if you ask people now, for example, in Lebanon, it is more important for you the cost of electricity or the availability of electricity. People will tell you the availability of electricity, because we had a lot of problems in shortage of electricity in the last years. While 2-3 years before, maybe the cost was more important. And this is the same for energy security. Not all factors will have the same weights all times. So for example, here we can see how the percentage of importance of the different criteria that affect energy security can change with time. Okay, so we can see a distribution of percentages for energy availability, infrastructure, energy prices, environment, social effects, government, and efficiency. All of these factors will affect energy security, but not in the same way. And these percentages will change over the years, depending on, as we discussed, the current situations, how people look at these different criteria, etc. Now, of course, the measurement of energy security is not something simple. And we discussed already last time, if you remember, whenever we have several factors that are not similar in a certain way, we come up with, if you want, a way to normalize the results, a way to put weights based on statistics, for example. And then we can try to come up with, after doing the normalization of results, we can try to provide numbers. And sometimes even you have, as we discussed before, criteria that are not directly related with numbers, but we make them related to numbers by saying, for example, and we can put a scale. Let's say if you want to compare to approach, as we have seen last time, you can put like a grade. And if I prefer, if I compare, as we said, A to B, okay, if for me the two aspects are equal, then I put as grade 1. While let's say if my reference is A and I prefer A much more than B, then I put a grade between 1 and 9. Okay, so even if the criteria is not directly qualitative and not quantitative, we can make it quantitative by putting grades based on a certain scale. So just as energy security was difficult to define, and the concept is changing over time, it is equally difficult to measure using one, few, and/or simple indicators. Instead, it is often studied using a basket of indicators that represent the variable dimensions it includes. Each of these indicators is given a certain weight according to the perceived importance, and an appropriate technique is used to combine them to give an index. So we already introduced together in class last time how to put indicators, how to identify their weights, how to normalize them, etc. And we'll discuss in this lecture also some important index that can be used to measure energy security. So the energy security indexes will be derived in this way and will be termed as composite indexes. Now, simple indicators that are to be used to measure energy security must offer 5 criteria. The first one is they have to be policy relevant. So, for example, when we talked about regulations, okay, let's say you want to force a certain industry or let's say a certain farm into using renewable energy to reduce the CO2 emissions. What you can do is you can impose a maximum level of CO2 emission. Okay, or also you can impose taxes on extra CO2 emissions. So this will be an incentive to use renewable energy. In addition, they have to be applicable to future systems. So whenever you put indicators, okay, we are not only interested about current situation, but also it should be projected to future systems. These indicators also have to be calculated using available and meaningful data. They must be data additional, meaning they add additional information when compared to other indicators, and they reflect vulnerability of vital systems. We'll see examples on these indicators. So first, one of these indicators is the import dependence. What do we mean by import dependence? It measures overall supply position of a country or a region for a particular fuel. Okay, for example, if you consider the ratio of net energy imports to the primary energy supply in any particular year, this would provide how reliant the country is on imported supply. So let us say, for example, a country consumes 100 million tons of oil equivalent, okay, which is, if you want, a unit of energy, and import 70 million tons of oil equivalent, then its import dependence will be just the ratio of the imported part, okay, over the consumption part. So here we can say that the import dependence is 70%, while the other part, let's say, will be provided locally. So of course, larger the percentage, this means that we are depending more on importing rather than using local resources. And of course, lower this ratio, the better is, because we do not have then to rely on other countries to supply energy. At a more and plus, it's not only important to know what is the amount of import, it's very important to know the resources. So let's say if I divide this 70 million into several parts, so let's say I import let's say 10% from Russia, 15% from the United States, not only from one resource, it's better, because let's say I have a problem with one of the suppliers, I still have another strategy, or I can ensure these resources from another place. So this will enhance the security, the energy security. So at a more disaggregated level, the import dependency by origin of supply could provide a more accurate picture of the risk. This is what we were talking about. Whenever I have several resources, I reduce then the risk of not being able to import, let's say, fuel as an example. Okay, so at a more disaggregated level, the import dependency by origin of supply could provide a more accurate picture of the risk. If a country depends on a single country for its imports, the risk is really high. On the other hand, a diversified source of imports will reduce this risk. Another important indicator is fuel mix. The fuel mix indicator shows the share of a particular fuel in the energy demand of a country, or it's important in the energy supply. How we define fuel mix? For example, if a country used 85% oil and oil products and 15% as to meet its primary energy demand, it cannot be said to have a diversified mix. This can be disaggregated to various sectors, like the industrial sector. So in general, even if you, for a certain source, you can use it in several ways, not just in let's say in one domain. Okay, so if you are using a certain product or that you are importing in several domains, this is better, because let's say you have a problem with one of the domains, so you are not being able to use it in this domain. You have a lot of chance to use it in other ways. But if you use 85% of oil, if you want directly, and only as oil products you have 15%. So you have a problem. In case you have any problem in this type of use, then you have a block and you will not be able to if you want to use this oil anywhere else, because you don't have a lot of choices to use oil in other ways. Okay, so it's good even for the same product, or let's say for fuel. You can use fuel to produce electricity. You can use a fuel, let's say, for cars. You can use it for any other, let's say, for generators. Okay, so whenever you use this product in several ways, then in case you have a block at a certain stage, you can use this fuel somewhere else, and you can avoid, if you want, accumulation of fuel. And in this way, and if you don't use it appropriately, يمكن ما نقدر نسوقه بالmarket. Okay, and this will be a problem for the suppliers. So the stocks of critical fuels indicator shows the availability of national stocks of a fuel and the length of time that the fuel could be used if supply disruption takes place. So of course, it's good to have stocks, but if you have a high amount of stock, you might not be able then to use it appropriately, and this will lead to high losses. Okay, so the stock of critical fuels can be an indicator and shows the availability of national stocks of a fuel and the length of time that the fuel could be used if supply disruption takes place, assuming current level of consumption. And for example, we can let's say for an IEA member countries, we should maintain a 90-day stock of critical fuels. Okay, of course you have a minimum to ensure, because it's good also on the other hand to have a high stock, because if you have any disruption, you don't have a shortage. Okay, and also on the other hand, it's not good to accumulate a lot of stocks, because you might not be able to use them in an appropriate way, and you can lose money then. So now we can talk also about indicators of concentration and diversity of supply. So as we mentioned, it's always good to have diversity of supply, because we can use any product in a more appropriate way. And in case we have a block from one side, we can use it in other sides. So to increase diversity, we should have balance, evenness in contributions. We should ensure variety, number of options in mix, and it's good to have disparity as degree of differences. So when we talk about variety, it is the number of diverse category of option into which an energy system may be used. So as we mentioned, let's say fuel can be used in several sectors: electricity sector, car sector, transportation sector, etc. So disparity differs to the manner and degree in which energy options may be distinguished. So we can talk how different are the options from each other. And for the balance, it is a function of the apportionment of the energy system across the identified options. So we can, if you want to talk about the question, how much do we rely on each option? Now, how we can consider indicators of concentration and diversity of supply. We have the Herfindahl-Hirschman index is generally used for market concentration analysis and is measured by the sum of the squares of the individual market share of each firm in the industry. The HHI ranges from 0 to 10,000, with the lower range obtained when very large number of firms exist in the industry, and the higher range is reached when a single producer is present. So here, if you divide, as we said, you can have several resources, and you can say 10%, let's say, is supplied from this company or country, 20% from the other, etc. So if more you divide it, okay, then it is better. So this index is used, يعني we'll take an example how to calculate it. Okay, this index is used to give an idea on the diversity of supply. So for example, if there were only one firm in an industry, that firm would have 100% market share, and then the HHI index would be equal to 10,000, indicating that we have just one side that is providing the product. If there were thousands of firms competing, each would have roughly 0% market share, and the HHI index would be close to 0. This means that when HHI index is close to 0, this is the ideal scenario, while if HHI index is equal to 10,000, this is very bad. For example, the US Department of Justice considers a market with an HHI index of less than 1,500 to be a competitive marketplace. An HHI index between 1,500 and 2,500 to be a moderately concentrated marketplace, while if we have an HHI index of 2,500 or greater than that, it is a highly concentrated marketplace. And the HHI shortcomings is that it does not take into account domestic production and political risks. Another index that can be used is the Shannon-Winner Index, SWI. Okay, and it's also, if you want, an index to judge if you have diversity, and it's calculated in the following form. So as we said, we divide the supply into percentages, and this SWI can be calculated as sum of from I going from 1 to n of xi ln xi, where xi represents the import share from each country. So it's like a percentage. When all imports come from a single source, the minimum value is reached. Okay, and for example, whenever you have, let's say, you have one source, this means that you have 100% for this source. Okay, and for all others, you have 0%. So if you apply, you know that ln 1 is 0. Okay, so if you apply it here, then you have 100% is 1. So 1 ln 1, then you get 0. This is why we say that whenever we have a value of 0, then this is the minimum value will indicate the worst case scenario, because then we have only one source. While if you have more, you have division of this percentage into several parts. Okay, this will increase the value of SWI, which is a good indication. Okay, so as the number of countries supplying the fuel increases, SW index will also increase. In SW value, and this is opposite to the other index. For the other index, you are summing xi square. Okay, and if you use it as percentage, this is why we said that whenever for the other case, when you have only one source and you do 100, you take it as percentage. Then you do 100 square, then you obtain 10,000, which is the maximum value. The maximum value will correspond then to the worst scenario for the other indicator. Okay, and 0 will be the best scenario, while for SWI it's the opposite, because the way of defining the index is different, because here you are multiplying xi by ln xi. This means that whenever you have just one source, 100%, xi is 1, and then you have ln 1 0, so SWI will be minimal. While when you have several sources and you do the summation, this will maximize SWI. So as a SW value below 1 will indicate a system that is highly concentrated and dependent upon one or at most two sources, which threatens security of supply. Whereas when we have SW value larger than 2, this will indicate a system with several sources, which could be considered relatively secure. The main limitation are also that the SWI cannot take domestic production separately from the imports, and the political risk cannot be incorporated. So here we don't look at the, if you want, at the type of sources. We just divide them into percentages. But in general, it's not only good to have a diversity of sources, but also we should have resources that we can trust, and that are not prone to a lot of risks. So from here, it is important not only to take into consideration the sources, but all the political risks associated with these sources. And this index, of course, will not be able to incorporate this. This is why we don't look only at these indexes, but also we look at the sources of of the supplies that we are, the products that we are importing. Now, also, if you want, because the indicators, okay, in general, we try to have, we modify the indicators to include, if you want, other factors. And for example, if you want to adjust the previous indicator, okay, we can do it in this way. If you want to consider the political stability factor into the index, we can do the following. We can add to sum of xi ln xi, we can add the factor bi. And what is bi? Bi is the political stability factor of the country from where imports are coming. So you know that each country can be associated with a certain risk. This is why we can define a factor that will tell us the degree of risks that is associated with this country. Okay, so if you want, we said together that whenever we have low value of SWI, this is bad. Okay, and high value of SWI is good. This is why we can say that whenever we have a country with high risk, this high risk can be incorporated through a low value of B. Okay, so where BI is the political stability factor of the country from where imports are coming. To include the share of indigenous production, the SWN index can be modified as follows. So we can also consider another factor, GI, okay, that can represent indigenous production for the country in question. So as you can see, the factors can be always modified in order to take into consideration other factors, let's say the political stability or any other factors that can be related to the diversity of supply. Now, so let us talk now how we can consider different index and how we can normalize them. We know that it's often difficult to assess energy security with simple indicators. And then we need a basket of indicators or metrics that is commonly used. And we already introduced together in last session the decision matrix and how we can add factors that are very different from each other. So we can consider also that in this case, we are talking about composite indicators. To consider composite indexes, we need to normalize, apply weighting, and aggregate, as we have seen together last time. Now, we have defined together last time one way of normalizing result, but it's not the only way. We have several ways to normalize the result. So as indicators used is a composite index that come in different units and scales, they cannot directly be combined without applying normalized processes. Normalization is the process through which they are transformed to a common scale so that comparison can take place. We have three common normalization approach, which are min-max, distance to reference method, and standardization. Last time we have seen one of the approach. Today we'll see together other approach that can be used to perform normalization. So let us discuss these different methods. Last time in class, we introduced the first method, which is the min-maximum normalization technique. Okay. In this technique, what we do is first we put, let's say, for different alternatives, we put grades. Okay. And then among these grades, we select the minimal one and the maximum one. So in the min-maximum normalization, the observed maximum and minimum values are used to scale the data within a fixed range, usually between 0 for the worst performance and 1 for the best performance. And in this way, for any of the alternatives, the scaled grade will be x minus x minimum over x max minus x min, where x is the indicator and min and max are the minimum and maximum value observed. Okay. Now, another, of course, also we have the problem is how to deal with outliers. So sometimes, okay, you are grading, you are doing a certain scale, but let's say you have any new factors that will, or any new alternatives that will come in place, then you might need to find again the numbers, because the maximum and minimum are can change. Okay, and we don't have also always absolute minimum and absolute maximum. So this will affect, depending on the alternatives you consider, this will affect the grade that you have. So it's not a stable grade that you will always have. So this might be an issue to consider. Another type of method to normalize is the distance to reference. What do we mean by this? The distance to reference measures the performance compared to a benchmark. You have, let's say, a case that is ideal, okay, and you can compare with. In its simplest form, it's expressed as a ratio of two values, and the reference point can be the average performance of the data set or the best performance of any other value. And you can consider, when you want to do this method, you need to define a reference. And defining the reference, we don't have only one way to define the reference. Okay, you have several possible scenarios. You can consider that I will say that the reference, to take into consideration different measurements, let me take the average value of the data as reference. Or you can say, let me consider the ideal case as reference. So you have several ways to put your definition. Okay, and from here you create also a new problem, that how to deal with the sensitivity of the score relative to the choice of the benchmark. Depending on the sample you studied, okay, you can have a certain average and ideal and max and best case. If you change the sample, you'll have new values. So this is why, in general, of course, to have a good idea, it's good to have large sample. It's good to have a lot of alternatives to minimize, if you want, the related problem with normalization techniques. Another way is the standardization, which measures the deviation from the sample mean. This is also known as the z-score. When the data value is equal to the mean, the score will be 0. If the value is below the mean, the score will be negative. And if the value is greater, the score will have a positive value. So it's like, if you want, as the name indicates. So, in statistics, you use the standard deviation. So you can see how far is my value relative to the mean. And we consider that if it's better, we'll have a positive value, and it's lower, we'll have a negative value. But all of these techniques, for each one, we have a certain problem. Okay, and for example, for the standardization method, we have the problem of interpretation of the score can be an issue, because as the previous cases, it depends on the sample we are considering, and it depends what is this, if you want, the deviations that can be acceptable, and what is, if you want, the level. And sometimes you can say, I can consider that the deviation, for example, if you remember in statistics, we considered, for example, samples of deviation between, let's say, 5 to 95%, and we disregarded the values that are very far from the mean. Okay, so we always have to put certain criteria in order to do interpretation of our results. But also, sometimes we can take subjective decisions. Okay, and we cannot say always that this is a perfect scenario that we consider. In general, sometimes each type of problems might involve one technique that will work in better than the others. Okay, I will open a new session.